The Philippines is one of the most natural hazard prone countries in the world. One of the most known environmental hazards is flooding. According to Pag-asa, the Philippines has a fairly well defined wet season. Aside from typhoons, there are other precipitation producing weather phenomena: tropical cyclones, thunderstorms, the ITCZ, frontal passages, etc. These phenomena are capable of bringing intense and excessive precipitation. Under certain conditions, a surfeit of rainfall results in a potentially disastrous phenomenon, which is a flood.
Pagkain. Halos lahat ng mga taga-barangay Rimos halos wala nang naisalbang mga gamit dahil sa baha.
Flooding is the most common environmental hazard worldwide and appears to be occurring ever more frequently around the globe, intensifying in some areas and also spreading into new regions. It is increasingly becoming a major contributor to personal and property damage worldwide, and in many places strikes without warning. To address the problem of a flood, while considering the economic aspects, the use of eco-friendly materials and local fabricated product may lessen the unit cost of the device and help to reduce the waste materials at the same time.
In all of this, we came up with a research entitled Development of Eco-Friendly Waterproof Doorway Stopple.
I am Tommy C. Borromeo.
I am Rose Anes Lagati.
I am Joseph E. Monte.
I'm Lauren C. Monte.
I'm Hermine Vasquez.
And we are the researchers of Track B1 from BSC 4B.
In this study, the researchers used the descriptive and developmental method in coming up with the eco-friendly waterproof doorway stopple. The descriptive method was used in designing the stopple in terms of dimension and mechanism. The developmental method was used in the development of the prototype.
To come up with a good research output, the first step to consider is planning. The design of the prototype has been created using the AutoCAD 2017 and SketchUp Pro 2021. To determine the materials to be used, the researchers evaluated the materials of the existing doorway flood barriers. Upon determining the materials, the proponents considered that the materials to be used must be cheaper yet quality. The researchers canvassed in physical and online stores. One of the researchers is the one assigned to fabricate the prototype. We use welding machine to completely fabricate the prototype. The width of the stopple is 0.8 meter, while the height is 0.9 meter. Through manual operation, the manual allowable stretch of the side wing arm is 1 meter on both sides, and the maximum allowable height of the stopple is 1 meter also.
In this study, the researchers used two types of doorway stopple prototype testing: the static head leakage test and the breeze impact test. They conduct three trial tests in the static head leak test, and all tests the researchers conducted was passed. For 200 mm, one-third DMWD, the average result of water leakage is 429 ml per hour, which is less than the allowable leakage of 500 ml per hour. Therefore, pass. For 400 mm, two-third DMWD, the average result of water leakage is 462 ml per hour, which is less than the allowable leakage of 500 ml per hour. Therefore, pass. For 600 mm, the average result of water leakage is 429 ml per hour, which is less than the allowable leakage of 500 ml per hour. Therefore, pass. After 4 weights of debris, the device withstand the impact of 94.176 joule. The debris impact caused 10 cm crack and movement on the surface, but did not affect the functionality of the device.
Concerning the design, in terms of dimensions, researchers make use of the standard width of doors here in the Philippines, which is 0.9 meter. For the height of the barrier, considering that the proponents focus on the design, the usual height of the available flood barriers was considered, which is 1 meter. And for the mechanism, based on a thorough study of the available flood barriers in the market, a fabricated scissor jack Fabricated machine bolt and neoprene rubber was chosen to seal spaces in between the product and the door where it will be put. Based on the findings and conclusions, product will be open for customization so that large openings and those places experiencing flood higher than 1 meter can also purchase the item and lessen damages caused by flood water. In selecting materials, select a lighter one to make the doorway flood stopple more easily to deploy and store. For the matter of wood door jamb, future researchers might think of additional materials or revise the mechanism so that doors with aluminum door jambs can also be used for the product. Since the product is eco-friendly, future researchers can also add more recyclable and environmentally friendly materials to be embedded in crafting the product. With the help of our very dedicated advisor, Engineer Yolanda A. Santorcas, this research entitled Development of Eco-Friendly Waterproof Doorway Stopple was successfully designed and fabricated.